here, it still won't let me have it.
Usually how I open my PDFs is with my Adobe programs.
I don't know how to.
You can.
Why is it like locked like that?
It's probably because it doesn't support PDFs. But I thought Word supports PDFs. Or am I wrong?
Possibly. Let me pause it. All right. Yes. Questions?
How can I get 5.7.1? Like I heard that ain't making sense.
So, let's see here. So let's do, is number 11 one of the homework assignments, I believe? All right, guys, we're going to go on and get started. We're going to go over one of the homework problems. Number 11. Okay. So we'll go over this here. Now, I think once you see what's going on with that, it'll make more sense. All right, guys, we're focusing in here. So number 11, this section part of it is determining if, from the given set of information, if it's direct, inverse, or neither. Now, direct, we had several different ways that we could write it, but the one we're looking at for this here, a equals y over x. Because again, this a value is a constant amount through the entire set. So whatever value of a we have will be the same for all these here if it is direct when we divide the y over the x. So if we look at this here, we're going to take 132 and divide it by 12. And we can do that in a calculator. 132 over 12 is 11, yes. Then we can move on to 198 over 18, which works out to be 11. 253 over 23 is 11. 319 over 29 is 11. 374 over 34 is 11. So since we got the same amount each time we divided, it tells us that this here is direct variation. It's direct. Because we have that constant amount for each time. And if we really looked at the equation, because for direct variation, the general form is y equals a times x. So here we don't have to find it, but this is defined by the equation y equals 11x. Gives us the whole thing. Now, if at any point doing this, if we got 11 on the first and then 9 on the second, we're done. It's not direct because that amount is not the same for every single one. Does that make sense? Inverse, the one we would use for this here is a equals x times y. So then we multiply the x and y's together. And if that, we go through and got the same amount like we did for here, 11 by multiplying the x and y's together, then it'd be inverse. And if we divide both of them like we did here and didn't get 11 every single time, if we multiply them together and didn't get the same number, then it's neither. Because that value of a should be the same every single time. Like here we got 11 by dividing them all. So it's direct. Now, I'm going to erase all these here. Because if we tried inverse, 12 times 132 is 1584. Then we can do 18 times 198. Yes. So see how we got two different amounts here? So it's not inverse. So the same thing would happen with when we were doing y over x. where we got 11, then got a different one? It's not direct, though. Does that kind of make sense? Because if it's direct or inverse, we should have this constant amount in relating the x and y to each other. Does that kind of make sense? So there's, again, it feels like there should be a lot more to it. But that's actually it. And we can go over more of it if we need to. Does that make sense? So, don't stress it at this point. We can still go over it. Because we're not going to be finishing the note sheets today. We will be finishing these tomorrow. And what we're looking at in 7.3 is multiplication and division. We're specifically looking at multiplication and division. And this is a little odd. And not so much that we're doing multiplication and division, but the fact that we're doing it first. There's most other chapters that we've covered, and most of the time, all the way up to this point, whenever we cover something, especially with operations, addition, subtraction, multiplication, division, division is normally the last one up that we look at. We always look at addition and subtraction first, then go to multiplication, and then division last. So it's a little different that we're going actually multiplication, then division before addition and subtraction. And that's partially due to the properties of fractions. Because as much as we would like, especially with 1/2 plus 3/5, we can't just straight add the 1 and 3, the 2 and 5 and get our answer. So there's a little bit more that we have to do, especially with addition and subtraction. Now, our first thing we talk about is, before we really start digging into multiplication first, is making sure a rational expression is simplified. Now, we consider a rational expression to be a fraction whose numerator and denominator are non-zero polynomials. Well, non-zero, zero just means it's zero. We don't have 0 on top or bottom. Because if we have 0 in the bottom of a fraction, it's undefined. If we have 0 in the numerator, the whole thing's just 0. So it doesn't help us. The domain of a rational expression excludes all values that make the denominator be 0. So here, 1 over x minus 1. Denominator is x minus 1, yes? What value of x would make x minus 1 be 0? Well, one way we can find is set it equal to 0 and solve. 1. Because if x is 1, 1 minus 1 is 0. So we said we could plug any x into this here, except x cannot be 1, because any value that makes the denominator be 0, we have to exclude. And that's what it means, rational expressions excluding values that make the denominator 0. We have to exclude those. A rational expression is in simplified form when its numerator and denominator have no common factor other than plus or minus 1. So if there's anything in common on top and bottom, we have to reduce it out. We have to remove it. Then it's simplified. There's no way that we can reduce the top or bottom of the fraction any further. And this here is also still on that first page. Simplify rational expressions, let a, b, and c be expressions with b not equal to 0, c not equal to 0. Because our a times c over b times c, c is in common on top and bottom. We reduce it, giving us a over b. Same thing's true with numbers. 15 over 65. Have a common factor of 5, we can reduce, giving us 3/13. The other example, the top and bottom have the expression x plus 3. More specifically, that it's the multiplication, we can remove those out. So if there's anything in top or bottom of the fraction, it has to be removed, it has to be reduced. So we kind of get that. But it's going to be better if we see it here. I still find it interesting, I do put this one first, and I do it on purpose, is if we look at this here, the numerator of this fraction is just the number 4, yes? The denominator is x times x plus 2. Is there anything in common on top and bottom? Well, there is 2 with 4 and 2, yes? But unfortunately, the 2 is trapped in with the x. X plus 2 is 1 full term. So we can't just simplify the 4 and 2. So is there actually anything in common? No, this is actually as simplified as it gets. If it had been 2x times x plus 2, that 2 and the 4 could simplify, because that 2 is not attached to anything with plus or minus. So this is actually as simplified as it gets. We can just say simplified. It's already done. We don't have to do a thing to it. Let's look at the next one. 2 times the quantity x plus 1 divided by x plus 1 times x plus 3. Yes? Is there something in common on top and bottom? Inside the parentheses, we have x plus 1 on top, x plus 1 on bottom. Yes? With multiplication, and I can do this out to the sides of this here. When we multiply two fractions, a over b times b over c, we multiply straight across, yes? So that means here that we have AD over BC. We're comfortable with saying this, yes? Now, these steps that we're about to do for here, we're not going to have to do them every time. I'm doing this to show you guys how this actually simplifies. Because when we multiply straight across to get here. But there's nothing saying that we can't go the other way. And specifically, I'm going to take this apart in one simple way. I'm going to pull out what's in common, because what's in common that we had on top and bottom was our x plus 1 and x plus 1. What we have left on top is 2 and our x plus 3. Because the denominators, x plus 1 and x plus 3 would multiply back together to give us what we started with, yes? 2 and the x plus 1 would multiply back together to get us what we started with. Because with multiplication, we can pull them apart, put them back together, just sit them next to each other, because they are just multiplying, yes? Now, the reason I do this is because over here, this. What is x plus 1 divided by x plus 1? Almost 1. Anything divided by itself is 1, because it's one whole term, yes? So our x plus 1 over x plus 1 is, for all intents and purposes, 1. So we just have 1 times our 2 over x plus 3. Well, what is 1 times 2 over x plus 3? 2 over x plus 3. Because we don't even need that. This is why it simplifies out. This will be the last time we write this out. Because we can see here with the multiplication, these here, if I get a marker, will just cancel out, giving us 2 over x plus 3. We can't break up addition and subtraction this way, but we can do it with multiplication because of this kind of property of multiplication. Because when we mark it out, really what we're doing is we're saying we have x plus 1 over x plus 1 times our 2 over x plus 3. The x plus 1 over x plus 1 reduces to 1, leaving us 2 over x plus 3. Now, before we move on, I'm going to state the restrictions. It's not necessarily asking for it, but I do want to state them. Because again, our restrictions are whatever's going to make the denominator be 0. And we have two different places it could be. Because our x plus 1 could be 0. Or our x plus 3 could be 0. Yes? Huh? Yes? Because here we're saying any value of x, yes? Because x is an undefined quantity. That's why we use it as an unknown value. And since we haven't put any restrictions on what x can be, it can be any real number. But we do have to put a restriction on it. Since we're dividing by x, well, here for x plus 1, minus 1. So if x is negative 1, it would make the denominator be 0, because it'd make the x plus 1 be 0. And when it's multiplied by our x plus 3, the whole thing would become 0. We're dividing by 0. That cannot work. So what we can say is that x cannot be negative 1. It could be anything else. Almost, because we still have the x plus 3. Here again, we can solve for x. We can subtract 3. So it's telling us that if x is equal to negative 3, it will cause the denominator to be 0. So x cannot be negative 3. If it doesn't ask for it on the homework, I'm not expecting it. But I do want us to see this because, again, it's something good to be in mind of. Because for addition, subtraction, multiplication, division, when we're not solving, it's not a big deal. But once we start solving, knowing this or getting in the habit of seeing these and remembering these is helpful. And the reason for that is because when we start solving rational equations, on some of them, these values will come up. And it's a part of the fact that, it's what we call an extraneous solution. It's a solution that does come about from solving, from the process of solving, but in the original context, it doesn't work. Does that make sense? And these extraneous solutions do come about in different places when solving, so it's good to be mindful of them. So we do have x squared in both, yes? But unlike this one here, x squared minus 4x minus 12, those plus and minus will come together. But if we look at the numerator and denominator, let's specifically look at the denominator first. X squared minus 4, is that factorable? We have two terms being subtracted, yes? So there's a good chance it's a difference of perfect squares. X squared, perfect square? Well, yes, x times x. Is 4 a perfect square? It is 2 times 2. So our denominator, x squared minus 4, will factor 2, x plus 2 times x minus 2. This is part of the reason we went back over factoring, because it will come up again and again with these rational expressions. Now the numerator. X squared minus 4x minus 12. So we have our two sets of parentheses with 3 spaces, yes? Third term is negative, so our signs are opposite. One's positive, one's negative. Factors of x squared are x and x. Factors of 12. One and 12, 2 and 6, 3 and 4. Yes? And now, yes, it would be 2 and 6. Now, in the previous one, we would pick one and try to go from there, yes? Now, for this to simplify, we need to have something in common on top and bottom, yes? So I could try 3 and 4. But either way I put 3 and 4, I wouldn't write this down. But I have something in common on top and bottom. Even if I switched the 3 and 4, would we have something in common? No. So out of all the factors that we have for 12, the only ones that would actually give us something in common is 2 and 6, yes? Now this is what I like, especially with rational expressions, when we start multiplying, dividing, and doing this, is that some of the other factors, once we get them factored, kind of give us a roadmap, an idea of what the others could be, because if this isn't 2 and 6 for 12, we have nothing in common. There is no way to simplify it further. That means it was already simplified. Yes, and we could check off to the side if we wanted to make sure. X times negative 6 is negative 6x. 2 times x is 2x, giving us negative 4x. And exactly. Any question on this here before we do the simplifying? So now we see that we do have x plus 2 in common on top and bottom, yes? And because it is multiplication now, we can cancel it out. We couldn't cancel it out before because of the addition, subtraction, it is holding it together. Here, we can do that. Because what it leaves us with is x minus 6 over x minus 2. Now, if we wanted to look at our restriction, yeah, we would. Now, we could solve it in two places. Here, we could solve the quadratic x squared minus 4, because that is the denominator, yes? Which isn't too bad, but I do have it in factored form here. Well, the factored form tells me that either x plus 2 cannot be 0 or x minus 2, which isn't bad. X squared minus 4 or x plus 2 and x minus 2. If we have more quadratics, we have to do more of our steps, our quadratic formula, all that there. Here, it's already in factored form. So here I can subtract 2 minus x cannot be negative 2 or positive 2. So our restrictions for this here, x cannot be negative 2 or 2. And we can put a comma between them, and that tells us our restrictions. Questions on this here? So for this equation, or this expression here, x minus 6 over x minus 2. X can be any number except for negative 2 or positive 2. Now, some books, I can't attest to all because I have not read every Algebra 2 textbook and do not have the desire to do that. But the ones we have and some that I've seen for a problem like this here would not state the positive 2. They would just say x is not equal to negative 2. And part of the reason is, if we look at the answer, x minus 2 is still a part of the expression, yes? So what they say is that, okay, we don't list the fact that x is not positive 2 because where we got that from is still listed. We only list our restrictions for expressions that are simplified out, removed from it. Since the x plus 2 is the only one that was removed from the denominator, the bottom, the part of the fraction that would cause it to be 0, that's the only one we list. Yes. Right, another way we could list this is x is not equal to plus or minus 2. That is the same thing. Yes. I think it's better to go on and list them. Yeah, I would rather list them all out. Even if it is still there, it doesn't hurt to list it. And it's really not that much work, more work to list that extra one than it is to just list one. So, and I tell you that because, yes, if you did or were looking at, I think, especially for the Big Ideas book, because they do have that selected answer list where it's listing only 1 instead of 2, bless you, that's why. Because they're not going to list any that are still left in the final statement. Any questions on this here? Sounds good. So, I'll go back and look at that and see where we missed. But luckily, we will hit whatever we missed again if we need to. If there are questions, please let me know. Actually, we'd already finished the problem. So all we missed was this here. Now, a plus b over c equals a over c plus b over c. So what we're doing here is just showing why we can't just cross out the x squared and x squared. Because when we add two fractions, the denominators have to be the same. If the denominator is the same, we add the numerators. Same thing's true here. For us to be able to, I'll subtract our x, have x squared minus x minus 12. If we split it apart, kind of like what we did with multiplication, how it would split apart is going to be x squared over x squared minus 9 minus x over x squared minus 9 minus 12 over x squared minus 9. I wouldn't write this out because I want you to kind of see this here. But in neither of the three cases did we have kind of x squared over x squared. X over that, or 12 over 9, we have 12 over our x squared minus 9, that whole expression. Does that make sense? And it's very, very common, and I've seen memes kind of about it on social media where they just go here and then simplify out. And this here, how we do addition and subtraction with that breaking apart and putting together with like terms is why it doesn't work. But as we saw with multiplication, the fact that we can split it apart and cancel out, that's why that one does work. So we kind of see the difference between those two. So here, we do have to factor these first. And luckily for us here, there is one of these that's a little bit easier, I think, easier to factor than the other. And that would be the x squared minus 9, yes? Because x squared minus 9 is a difference of perfect squares. Because what times itself is x squared? X. We'd have our plus and minus. What times itself is 9? 3. So we'd have 3 and 3. And this kind of helps us get an idea of what the numerator should be. Because x squared minus x minus 12, 12 does tell us the signs are opposite. X squared is x and x. Factors of 12 are still 1 and 12, 2 and 6, 3 and 4. Well, if we want something to simplify, we're going to use 3 and 4. But incidentally, 3 is going to be positive, the 4 is going to be negative. And if we did check this here, our 3x times negative 4 would be negative 4x. Positive 3 times x would be positive 3x, giving us negative x. Questions on how we factor this? Yeah. You're welcome. So looking at this here, what do we have in common on top and bottom? Our x plus 3, yes? So x plus 3 over x plus 3 would simplify, leaving us with now again, we can find the restrictions. X plus 3 equals 0. Let's focus up here, guys. We can minus 3 from both sides. Yes? Question?
I think I figured
Because on one of them we would add 3 to both sides, the other we would subtract, depending on how you listed them out. Because it doesn't matter which one we solve for first, we just have to pick one and do it. So if we wanted to combine these here, we could list them out separately. We can do x is not equal to plus or minus 3, but those would be our restrictions. Questions on these here so far?
Yes, sir.
I can get them out. Yeah. Leave that crack because I think she might be coming back. Huh? It would, because 4 and 6 do have a common factor of 4. But the plus, x plus 4, kind of as we split it last time, does it kind of split there. Now, x plus 4, as we said last chapter, here, the degree of x plus 4 is 1. So x plus 4 is actually factored as far as it goes. It is simplified as it'll get. Because there is no common factor between x and 4 besides 1. There's no way to factor it. There's no way to simplify x plus 4. If we look at the denominator, x squared minus 16. Yes, it is a difference of perfect squares. which gives us our x plus 4 and x minus 4, yes? Yes. Is there something in common on top and bottom? And that would be our x plus 4 and x plus 4, yes? So these would simplify. Because the denominator would remain x minus 4. And again, when anything simplifies out completely, it reduces to 1. So this just reduces to 1 over x minus 4. Right. X plus 4 equals 0, we can subtract 4, telling us x cannot be negative 4. And our x minus 4. So if we want to make this one statement, we can leave it as 2 statements or put it as 1. X cannot be positive, negative 4, plus or minus 4. That's it. Questions on these here? We'll finish up with this one here. Now, this one here, x squared minus 2x minus 3. Guys, focus up here. And x squared minus x minus 6. There's not one that was a difference of perfect squares. That's kind of easier to factor. What I would suggest on these like this here, pick whichever one you see the factors of first or see the factors of easiest. So if we do the numerator, we would indeed have opposite signs because 3 is negative. Factors of x, and x. There's no other factors at 3, and it does work out to be x plus 1 and x minus 3. The denominator would have opposite signs. X and x. Yeah, there's 1 and 6, 2 and 3. And the only way for this to have something in common is 2 and 3. And the 3 has to be negative for us to actually have something matching. At this point here, those would cancel, leaving us with x plus 1 over x plus 2. And we did go a little quick through these last two. This one here. And our restrictions. X plus 2 equals 0. I got it from the one we canceled out. Because when we canceled out the x minus 3 over x minus 3, even though we did cancel it out because it does show up in the denominator at one point, especially the original, it can't be that solution.